Let's come down here and let's dive right into an example. So some of these are pretty familiar to us. Now, we talked about this being periodic, that this period repeats itself going forever to the right and left. So that means, guys, domain is the easiest one of all. Unless you see any sort of asymptote or hole in your graph, your domain, which we're really not going to see in this class, your domain is going to be negative infinity to infinity. Now the range is a little. We got to think a little bit more about the range, right? As we look, this curve, this repeated graph here does not go up forever or down forever. Notice the highest this graph ever gets is +4, and the lowest it ever gets is -4. We also see that -4 and +4 are included in a point on that curve. So my range, the lowest value of my range is -4. The highest value of my range is +4. And since those values are included, we don't really need to write +4. Sorry. You don't really need to write that there. We could just write 4. 4, that would be my range. Since this does, and again, this does go forever to the right and the left there, so that's why my domain is negative infinity to infinity. All right, so let's talk about relative max and mins. Now, this is where this gets a little tricky, and this is something that's a little bit different than what we've seen before. And we're going to see this not only in relative max and mins, but also in our zeros here. So I can see I have a relative maximum right here that has a height of 4. This is a relative maximum. Now, if this graph were to keep going to the right and left forever, notice that it's going to come down, come back up, and I'm going to have another relative maximum. This is going to come up and have another relative maximum. There are an infinite number of relative max and mins. All right, the question is, how far does it take for one relative max or min to get back to another one? Right, so if we look here now, this is where we talked about working in radians. You can see, guys, the x-axis of our graph here is in radians. It's the x-axis of our trig functions is almost always going to be, guys, listed in radians here. So we're going to have to be able to work with fractions. We talked about that in the previous set of notes. So if I go from -3π/2, all right, so I start here and I go all the way to +π/2. How far is that distance? How long does it take horizontally to get from one relative max to another relative max? Well, -3/2 to +½ right? This is actually 2π. And so what this tells me, because this is periodic, because that's going to repeat itself, that every time I find a relative maximum, I can go to the right or to the left 2π on the x-axis and end up at another relative max or min. And because this graph goes on forever, I can do that an infinite number of times. All right, so here's how we're going to describe this relative maximum. The relative maximum, and so what we're going to do first is we're going to pick one. I'm going to pick π/2. All right, so the x-coordinate of that relative maximum is π/2, and the y-coordinate is 4. So that is a relative maximum. But again, there's an infinite number of relative maxes. So how do we express that if I start at this one relative maximum, I can go 2π units to the left or 2π units to the right forever and keep adding another relative max to my list? Well, what we're going to do is we're going to add or subtract. So that's going to the right or going to the left. 2π. Now, that would be doing it once. All right, if I add or subtract 2π, that would be going 2π units to the left once and 2π units to the right once, which would mean I would have 3 total, 1, 2, 3 relative maxes. But I want to do it an unlimited number of times. So what we're going to do is we're going to put the variable n after 2π. N is going to represent the infinite number of times that I could add or subtract 2π. So we can put that down here. N represents that we can add or subtract an infinite, that's not how you spell infinite, infinite number of times. All right, so that's going to be important. And again, guys, this might be a little confusing now, but you're going to see this will be something we're going to pretty much do every single time we're working with a sine or cosine. Excuse me. So I think it'll get pretty familiar to us as we go forward here. So let's talk about relative mins. Well, relative mins, take a different color. I've got one at negative pi over 2, and I've got one here at 3 pi over 2. And we can see that again, the same way. It's going to be repeated over and over again. So what's the distance to go from one to the other or back from negative 1 pi over 2 to positive 3 pi over 2? That is also a distance of 2 pi there. Right? So relative min is going to work the same way. I'm going to choose a relative minimum to start at. Okay, let's start at negative pi over 2. So I'm choosing this as my starting value there. Let me circle. Probably a good idea to circle the one that I chose to start with up here. And then again, we're going to do the same thing. We're going to add or subtract the distance it takes to get to another one, another relative minimum, 2 pi, n times, an unlimited number of times. And the nice thing, guys, is the y-coordinate, though, never changes. Notice, no matter how many relative minimums I hit, the y-coordinate I don't have to worry about because that's always going to be negative 4. So let's talk about absolute max and min. Well, absolute max and min, guys, are pretty easy, and they're going to come from the relative max and min. What is the absolute lowest y-coordinate range value we get to? Well, it's negative 4. Boom, we're done. Absolute max, what's the highest absolute y value or range value we'll get to? Positive 4. Pretty much, guys, whatever the number is in your relative max and min for the y-coordinate, that's going to be your absolute max and min. So that's pretty nice and easy. All right, y-intercept. Well, there's only going to be one y-intercept here. And in this case, that's pretty easy. Just like we've always had, we find the point where the graph crosses the y-axis, and that is our y-intercept. Now, where things get a little tricky again is in our x-intercepts. So you can see in this graph, guys, I've got an x-intercept right here, right here, right here, right here, and right here. So the question becomes then, that's 5. Well, how many are there? Again, this is a periodic function, so it is going to repeat itself forever. So there's an unlimited amount. We are going to describe our x-intercepts the exact same way we did our relative max and mins. We're going to start at 1. So I'll start at pi here, and you can see the distance between one x-intercept and another x-intercept is pi units. Either way, if I go to the left or the right, it's pi units. Now, there will be times, guys, where depending on how your graph gets shifted up and down, you may have to describe 2 different sets of x-intercepts, but that's we'll talk about that more when we come across an example like that. A lot of times, this is going to be the situation where notice the distance between every pair of consecutive x-intercepts is indeed pi. All right, so my x-intercept here is going to start off with pi. Because I'm starting at pi, and then plus or minus pi, which is the distance n, because I can do that an unlimited number of times, and then the y-coordinate for all of those is, because it's an x-intercept, going to be 0. Now, the zeros are pretty easy as well, guys. The zeros come directly from this. The zeros are just going to be the x-intercepts of the x-coordinates of the x-intercepts. So whatever I have here for my x-intercepts, I just pull that down, and that's my zeros. So that's all of the characteristics we're familiar with. Notice relative max and mins and x-intercepts have a little bit of a change, but everything else is pretty straightforward. So let's take a look at our amplitude. Let's go with pink here for amplitude. So again, we can see that our absolute maximum is at 4, and our absolute minimum is at negative 4. So we can see that that's a distance between the two of them of 8. Well, we talked about up here that the amplitude is half of that distance from the max and the min. So half of 8, our amplitude would be 4. Also, you can kind of see here that 4 and 4 kind of give us that distance there. The amplitude, even though the distance is 8, guys, the amplitude is actually just this right here. That's the amplitude, and you can see it's repeated. It's kind of mirrored above and below what looks kind of like this middle line that goes right through kind of the middle of our curve. Well, hey, guess what that's called? That's called our midline. Let me find a color we haven't used here. We'll use bright green. And guys, what we see here is we see kind of a horizontal line that essentially cuts our graph kind of in half, right? You can see that as much as above as is below. Now, it's not a reflection. It's not a reflection, but it's kind of creates this halfway dividing line. And we talked about that was halfway between the max and min as well. So if we take the maximum 4 and negative 4 and add them together, we get 0 divided by 2. Our midline is y equals 0. Again, guys, both of these amplitude and midline, I think, are going to be very easily recognizable visually when you make your graphs. So I think you're gonna not even really need to do this kind of distance thing and the adding of the max and the min to get that. I think that's gonna kind of make sense to us without having to do that. But that is always something we can do. Now, period. This is a little bit trickier because there's probably a lot of different places. Well, there are a lot of different places you could pick as a starting point to judge how long it takes for the period to repeat itself. It doesn't really matter where you start. The important thing is that you pick a point and then you follow the curve until you get back to a point that has the same y coordinate, and here's the important thing, and the graph repeats the same pattern from that point. So I'm going to pick, I'll just start way over here. I'm going to pick this point here. So I'm starting at negative 2 pi. So I'm going to go up from negative 2 pi, hit a maximum, go down. Now I've hit a 0 again, an x-intercept. But notice what I did originally was start at an x-intercept and go up. Here, this x-intercept goes down. So again, I'll hit a minimum, I'll come up, and I'll hit another x-intercept right here. And notice what happens. The pattern repeats itself. So x-intercept going up, x-intercept going up. I know from that x-intercept to that x-intercept, from this point to this point, it is one full pattern that will repeat itself. So from negative 2 pi to 0, right, that is the distance it takes for my period, and that distance is 2 pi. 2 pi in distance, guys, is always positive. All right, so that's another reason why we called it distance, because distance is always positive. Maybe we should write that up here to remember that distance. All right, distance is always positive. All right, well, we've kind of worked through these notes, guys, and the best thing to do at this point is just to practice, just to dig in and try it and figure out what questions you have, what makes sense visually, what doesn't, and then please, guys, ask, engage. Friday, we'll be doing a Zoom chat again that you can come on and ask questions about. So that would be a great time to do it if you don't feel like ClassKick or email or something is a good way to kind of communicate what your question is. Hopefully this was informational and you understood it all and you can dig right in and get going. All right. Thanks, guys, and I'll see you in the next video.